We're now ready to learn two new properties, the multiplication property and the division property. And pay attention to how they differ from addition and subtraction that we learned previously. What is division for segments saying? It's saying that if I know that AB is 24 inches long, and I know that M is the midpoint of AB, then I know that A to M is half the length of AB and MB is the other half. So I know that AM is 12 and MB is 12 because 24 divided by 2 is 12. If I also know that CD is 24 inches long and N is again the midpoint of CD, then I know that CN and ND are both half of 24, and 24 divided by 2 is 12. What division is saying is that if two segments are congruent, then a half from one will be congruent to a half from the other. That's different from talking about when AM is congruent to MB. AM is congruent to MB because of the definition of a midpoint. I don't need the division property, nor is the division property created to tell me that one half of AB is congruent to the other half of AB. I need the division property to tell me that if two whole segments are congruent, one here and one here, then a half from one will be exactly the same length as a half from the other. What does division mean for angles? Something very similar. If I know that angle ABC is 120 degrees wide, and that BX and BY are trisectors, then I know that within each section of this angle, there is 120 divided by 3, 40, 40, and 40 degrees. If I know that angle PQR is also 120 degrees, and I know that QZ and QW are also trisectors, then I'm going to take the 120 degrees for angle PQR, divide it by 3, and find out that I have 40 here, 40 here, and 40 here. Again, I don't need the division property to tell me that these three angles are congruent. Trisection tells me that. I need the division property to tell me that a third from one angle is exactly the same size as a third from another angle if both angles start out the same size and I do divided by 3 both times. What does multiplication mean? Something similar but sort of in reverse as you'd expect. If I tell you that AX has 8 inches and that X and Y trisect AB, then I know that AX equaling 8 inches is only one of 3 equal numbers within AB. So if AX has 8 inches, then 8 times 3 is 24 is the number of inches in AB. Similarly, if I tell you that ZW has 8 inches, and Z and W trisect CD, then I know that CD is made up of 3 of these, and 8 times 3 gives me 24 for CD as well. If a third from one segment is exactly the same size as a third from the other segment, and to get the whole segment, I have to multiply this third by 3, and to get the whole CD, I have to multiply this third by 3, then I'm going to be doing the same number times 3 will give me the same answer. Multiplication says that if a third from one segment is the same size as a third from the other segment, then the segments must be the same size. Let's look at multiplication for angles. Suppose I tell you that angle 1 has 60 degrees and that BX is a bisector, which means that ABC is twice as big as angle 1. That means that 60 times 2 will give me 120 degrees for angle ABC. If angle 5 has 60 degrees and QY is a bisector, then I know that angle 5 represents half the degrees inside of PQR, and if I double that number, 60, I'm going to find out how many degrees are in the whole PQR. So if a half from one angle is congruent to a half from another angle, then when I double this number and I double this number, I get the same answer for both. If halves from different angles are congruent, the whole angles must be congruent. That's what multiplication says. Let's consider the following two examples and use them as an opportunity to compare the differences between multiplication and division that we've just been discussing and addition and subtraction that we learned previously. You'll notice that one diagram is used for both examples. One diagram, two examples, and to make it more interesting, we have the same conclusion in both. So what's the difference? In example A, you were told that angle 1 has the same number of degrees as angle 5. There are no bisectors in here, so I have no idea if angle 1 is the same size as angle 2. I don't know if angle 1 is smaller or angle 1 is bigger. All I do know is that angle 1 and angle 5 have the same number of degrees. I also know that angle 2 is congruent to angle 4. So now angle ABC is taken up by an angle that has the same number of degrees as this angle, and a second angle that has the same number of degrees as this angle. So I can now find the measurement of angle ABC, so to speak, by doing what to the number in here and the number in here. I can find out what information about the size of PQR by using the number in here and the number in here. Angle ABC must be congruent to angle PQR, that's right, because addition guarantees that if I add the same two numbers here and the same two numbers here, I'm going to get the same answers here. Look at the difference in angle B, question B. If I know that angle 1 is the same size as angle 5, but I tell you nothing about 2 and I tell you nothing about 4, then I need something else to help me figure out the answer to this question, and here it is. BX bisects. Angle 1 is half the degrees that angle ABC has. Angle 5 has half the degrees that angle PQR has because QY is also a bisector. So I can find the measurement of angle ABC by doubling this number, and I can find the measurement of angle PQR by doubling this number, and because they're the same number, I'm going to get the same answer. So angle ABC and angle PQR have to be congruent by multiplication. Here's the segment problem. Again, same diagram, same conclusion, different givens, different reasons. If I tell you that A to B is the same length as C to D, and I tell you that X to B and C to D, and C to W, if C to W and A to and X to B use up the same amount of space, then why does AX and WD have to be the same length? If these two are the same length and these two are the same length, then why does this little piece here have to match this little piece here? That's right, subtraction. Now look at the difference over here. I'm willing to tell you that AB is congruent to CD the same way I did over here. But I'm giving you no more information about any of these segments directly like I did over here. I am willing to tell you, however, that X and Y creates thirds and that Z and W create thirds. So if AB is the same length as CD, why does AX over here have to be congruent to WD over here? Answer: because a third from one segment has to be equal or congruent to a third from another segment when the segments started out the same numbers to begin with. So AX is congruent to WD by division.